This video is for anybody in the construction sector who needs to understand how to develop a construction project schedule. In this video, we're going to take you through from the start to the finish, the steps you need to go from a project scope or an idea and turn it into a plan of how to deliver the works. We'll show you how to create a step-by-step plan that's called a construction project schedule. And this video is part of our series of talks we're doing with the goal of equipping junior construction professionals and junior construction engineers with the skills they need to deliver and manage a project successfully. And in these talks, we're talking specifically about construction project scheduling. And it's one of 4 talks we'll be doing on the topic. We're going to be covering step by step what you need to go from understanding a schedule to developing it, to implementing it and creating a short range program, and then to track and monitor progress. And this is the second talk we're doing. We've already covered the basics of construction project scheduling, looking at the role and its importance. In this talk, we're going to look specifically at how to develop a schedule. This means taking the idea or concept for a project, looking at the drawings and specifications, and turning it into a sequence network of activities that shows step by step what has to be done to finish the project, when these activities have to occur, and the linkages between the activities. And all of this will be covered and put together in a Gantt chart. Project scheduling is just one of the 6 fundamental construction project engineering skills we're going to be looking at in this series of talks. We're also going to look at quality management, procurement and contracts, design management, construction cost estimating, and construction cost control. A little bit about us before we get started. My name's Tim. I'm a senior project engineer with almost 10 years experience in the industry. I've also got my PMP, so project management professional, and I'm a chartered professional engineer in electrical engineering and project management. I've been making these talks with my colleague Ashley, who's a senior commercial risk management with 15 years of experience in the industry. And together, we've got a learning academy, Construct IQ, where we've helped over 20,000 students accelerate their careers by mastering the construction project management fundamentals. And we know that by mastering these core skills, you can accelerate and grow your career. And over 94% of students that we've surveyed said that we've helped accelerate and grow their careers by mastering the fundamentals. So specifically in this talk, we're going to look at understanding the process to develop a construction project schedule in detail. We're going to look then at a detailed example of how to create a schedule. We're going to look at some applications of this on real life projects. And then we'll look specifically at the role of a construction project engineer in developing a project schedule. In the previous talk, we answered why would we want to create a schedule? And so in this one, I'll just briefly touch on the schedule is a tool we use to sequence and schedule construction works. We use to plan and manage a project. But it's also a tool we use to engage stakeholders and keep our client informed. But if you want a more comprehensive answer to that question, go back and look at the previous video, and we'll cover in detail the importance of construction project scheduling. So how do we build a schedule? Well, we follow a series of steps called the schedule development process. So if you think about what a schedule is a plan of how to build a project. The best analogy I can think of what an ideal schedule should be is you can think of it like an IKEA instruction manual. You start off with an idea of a couch or a bed you need to build. What you want is a document that shows you clearly every step you need to follow in the process to turn this set of parts into a finished product. But that's what we're going to understand in this talk. What are the steps we need to follow to create our IKEA instruction manual of how to build a $100 million, $200 million construction project? So when we create a schedule, there's 6 steps we're going to follow. The first one is we need to identify all the tasks that we need to complete the project. The second step is we need to put them in order. So we have to work out what is the sequence we need to complete these tasks. The third step is for each of these tasks, we want to estimate how long we think it will take. Fourth is we're going to then combine all this information together into a schedule model. So this is something like a Gantt chart. The fifth is we need to then optimize and analyze the schedule. We need to make sure that it meets the project needs. We're not violating any constraints, and then we're going to finish on time. If not, we'll have to go back and create iterations of our schedule, change, optimize, and analyze things to make them better. And then when we've created this model, step 6 will be to engage with our stakeholders, so both internal and external stakeholders, explain to them the schedule, explain to them the logic of the schedule, explain to them the assumptions of the schedule, and to get their buy into it. Because a schedule has no value if people don't agree with it. So step number 1 is to identify all the work that we need to do to complete the project. This means creating our activity list. Our activity list where we create a list of all the tasks that are needed to complete the project. This is also called a work breakdown structure, where we take the overall project scope and decompose it into a series of activities. Looking at an example work breakdown structure of a road project, we'll break the project scope down into separate levels. So the first level would be where we take the road project and we break it down into earthworks, structures, utilities, and roadworks. Then, under each of these separate activities, we can break it down further. So for example, earthworks, we can break down to clearing and grubbing, where we remove existing vegetation, the bulk earthworks, so this is our bulk cut and fill, then any drainage we need to do, and then subgrade preparation for the road. So you can see we've started with the road project, we've broken it down into key disciplines, and then under that, we've broken everything down further into sub-activities. And when we create a work breakdown structure, we want to add more and more detail as we go through the different levels. So we take street lighting, for example. So we've gone from a road project into utilities, into street lighting, and then under street lighting, we can break that down into pits, conduits, and foundations, light poles, distribution boards, and circuits and luminaires. And remember, when creating a work breakdown structure, there's really no right or wrong answer. You could have broken it down 100 different ways. Say, for example, you didn't even have to going back to the level 1 work breakdown structure, we didn't even have to break it down into earthworks, utilities, or this. We could have broken it down by phases of the project. We could have said design, pre-construction, construction, commissioning. Now, maybe that wasn't the most logical way to do it, but it's a different alternative. So the hard part is coming up with the right way to create a work breakdown structure that matches the project you're on and is the most logical way of doing it. But as you see, so street lighting we've broken down into pits, conduits, and foundations, light poles, distribution boards, and circuits and luminaires. Then the next level under this, we could say is the lowest level, which is our work packages. So then under pits, conduits, and foundations, we can break them down into, say, Zone A, Zone B, Zone C, and Zone D. Our work packages are the lowest level of the work breakdown structure. So we've broken the overall project scope down into the smallest component task or piece. So your work breakdown structure could have 10 levels, could have 20. For this example, we're only doing 3. But for a bigger project, you're going to have more. And for a smaller project, you're going to have less. And these are our smallest tasks. Now that we've created our task list, the next thing we have to do is work out what order the tasks need to be completed in. So this is where we create the network schedule. And every single task will have linkages. So this means there's a task that needs to be completed before it can start and a task that needs to be completed after. There's 2 main types of linkages we need to consider on a project. These are called mandatory and discretionary. A mandatory linkage is where tasks need to be completed in a certain order. There's no other way around it. It's a physical impossibility not to do it. For example, if we're doing the foundation of a light pole, we first need to drill the hole before we pour the concrete. It's impossible to pour the concrete for a light foundation without the hole. Discretionary linkages, on the other hand, are linkages we choose to put in place for other reasons. So it might be more cost effective to link things in a certain way. It might be help manage risk. Discretionary linkages are effectively ones that don't need to be in place. So for an example of a discretionary linkage would be resourcing. The light poles in Zone A don't need to be installed before Zone B. However, because we're constrained by resources, we're choosing to do Zone A before Zone B. Now we could get more resources, and this would remove the discretionary linkage. So you can see it's not the same as a mandatory linkage. Now, because there's so many discretionary linkages and considerations when creating a project schedule, for the first cut of creating a schedule, only put in place the mandatory linkages. That'll make your development process much, much easier. When you go through and iterate and improve the schedule in step 5, when we optimize and analyze it, This is when you can consider things like resourcing or other constraints that are going to impose discretionary linkages on the schedule. Going back to our example road project, let's look at the street lighting in Zone A and how to create a network schedule. So the first thing we need to do is we need to have the earthworks complete in Zone A. This means that the road will be at the correct level and the subgrade will be ready for the conduit installation. First thing we'll do is we'll do our street lighting civil works. So we've got to do our pits, conduits and foundations. Then you can see on the screen, we've also got a 5-day lag after the foundations are done before we can stand our light poles. And this is for the concrete curing time. But once we've done our pits, conduits and foundations, we can install the distribution board, we can install the light poles, and then after these activities are done, we can put in place the interconnecting cabling between them. So the cable from the distribution board to the light pole. After that, we've finished our street lighting install for Zone A. And so you can see this is just purely a schedule that shows the linkages between the activities and what order they need to be completed in. Okay, so now we've got a list of activities and we know the order they need to be completed in. The next step is to estimate the duration of each of these activities. We want to know exactly how long each task is going to take. Now there's 3 ways we can do this. We can do a top-down estimate, a bottom-up estimate, and a parametric estimate. And I'll explain all of these in a second. We also need to consider whether we're self-performing the task, so using our own internal labor, plant, and machinery to complete the construction activity, or whether we're subcontracting it, so engaging a supplier, subcontractor, or vendor to complete the task on our behalf. And then we also need to consider, when working out how long something's going to take, we need to consider the scheduled calendar. Basically, this is a way of saying we need to consider the available working time we have to complete the task. Top-down estimating. So top-down estimating is like saying an activity on another project took us 2 weeks to complete, so therefore this activity, because it's similar, should also take 2 weeks. It's basically making broad, high-level comparisons between tasks. And it's quick and easy, but it's also it can also be inaccurate because you're not considering specific project constraints. So for example, if we're saying on another project, trenching took us 3 weeks, but on that project we had 2 kilometers of trenching, and on our project we've got 8 kilometers, then it's not an accurate comparison. We can improve a top-down estimate using parametric estimation. So this is like saying if 100 meters cubed of excavation on another project took us 3 days, then 1,000 meters cubed should take us 30 days. It's basically adjusting a top-down estimate by a base quantity. You're still assuming productivity and site conditions are the same, so it's still quick and easy, but the specific quantity and volume of the task is now considered. However, any specific site constraints are still going to be missed with a parametric estimation. So for example, if we use the trenching example, and 2 kilometers of trenching took us 1 week, so we're saying 8 kilometers is going to take us 4 weeks because we've adjusted by the length of the trench. We're also not considering things like the amount of rock in the ground, maybe the amount of wet weather we're going to get, the type of plant and machinery we're using, the size of the trench. While a parametric estimate is still easy, it's still not very, very accurate. And so the most accurate way we can estimate the duration of a task is with a bottom-up estimate. This is where we create an estimate, or it's the opposite of a top-down one. We're building an estimate from the bottom up. We're going to look at the specific activity in detail, come up with a productivity, and look at the quantum of works. Bottom-up estimates are the most effort, but they're also the most accurate. And we can combine all 3 ways of estimating together. We can build a bottom-up estimate, but then also check it with a parametric estimate. So for example, if we do a bottom-up estimate and we come up with a completely different figure than a parametric estimate from another project, it's a red flag that our bottom-up estimate was wrong. So to build a bottom-up estimate, we're going to take a quantum of work. So this is something we'll measure from the design drawings, like 1,200 meters of trenching. We then need to divide this by productivity. Now, productivity is the rate we're doing the work. And this is going to be a function of 2 things. So it's going to be a function of our activity resourcing, so the number of people, plant, and machinery have allocated to the task, and then the specific productivity we've come up with for the task. So we'll consider things like the type of plant and machinery we're using, the method of excavation. So for example, if we're using hydro excavation, our productivity is going to be way slower than if we're using a 30-ton excavator. You then divide the quantum of work by the productivity per shift to get you the number of shifts it takes to complete a task. So 1200 meters of trenching, if we're doing 40 meters a shift, it's 30 shifts of work. Now, bottom-up estimates we use when we're self-performing the works. This is where we're using our own labor, plant, and machineries to complete the tasks. And for these activities, we should do a full bottom-up estimate and then cross-check it with a top-down or parametric estimate. The other way we can do works is we can subcontract them. Now, subcontracting is where we engage subcontractors and suppliers to do work on our behalf. For these tasks, because we've engaged the subcontractor to complete a scope within a fixed time frame, we can look at the contract durations and the timelines we've agreed with them. Now, contracts might not be specific enough. We might be developing a schedule at a time before we have subcontractors. In that case, we just need to engage with our supply chain and understand how long it's going to take them to complete the works, and then work out if this matches our requirements for the project. And then we need to work out with them how long they need to do the work, how long we need them to do the work, and come up with a solution. Against really important subcontract packages that have, for example, impact the critical path, we should always do an independent bottom-up estimate to cross-check what they're telling us. When we did our bottom-up estimate, or when we're talking about durations, we're going to say an activity will take 30 shifts, an activity will take 40 shifts. How long it takes us to do these 40 shifts, so 1 calendar month, 2 calendar month, 3 calendar months, depends on our calendar. Schedule calendar can be thought of as the time available we have to complete a task. It determines the available working hours. So for example, if our site's only open Monday to Friday, 7 a.m. to 5 p.m., then this is going to be significantly different to a site that's open 7 days a week doing day shift and night shift. In one example, you have a scheduled calendar that only has 5 working days, 5 shifts in a week. In the other example, you have a calendar that has 14 shifts in a week. So the same trenching activity that takes 30 shifts in the Monday to Friday working week will take us 6 weeks to complete. In the other example, will take us 2 weeks to complete. Now, there's also some other things that impact the schedule calendar. These are things like public holidays, the amount of inclement weather, and other considerations. Again, let's go back to our example of the street lighting works on a road project. So we've broken it down into 2 sets of activities. We've got our self-performed civil activities, and we've got our electrical subcontract activities. So for our civil scope, because we're self-performing the task, we're going to complete a bottom-up estimate. So let's say we've got daily working hours of 10 hours, so 7 a.m. pre-start and 5 p.m. finish. In this, we'll factor in 3 non-productive hours. So these are things like the pre-start meeting, lunch breaks, mobilization to site, and setup. This gives us 7 productive hours. Then, for each task, we need to factor it. We want to come up with a productivity per hour. So when the crews are fully working, fully engaged, how much work can they get done per hour? So conduit installation, we'll say is 20 linear meters per hour. Pit installation, they'll do a pit every 2 hours, so 0.5 pits an hour. And then foundation installation, again, they'll say they do a foundation every 2 hours. So this information, I obviously can't cover how to come up with every productivity for every activity in this talk. But for these sorts of activities, to come up with the conduit installation of 20 meters per hour, you want to engage with subject matter experts. So these are people who understand the work and understand what's involved and understand the durations. And again, we can also look at historical data from other projects. We can then convert all these hourly productivities into an installation per shift. So 20 meters per hour of conduit installation gives us 140 meters a shift. Pit every 2 hours gives us 3.5 pits per shift, and a foundation every 2 hours also gives us 3.5 foundations per shift. So next, we want to convert these installations per shift to a total duration to complete the task. So for our total conduit quantity installed, we'll say is 3,500 meters. If we're doing 140 meters per shift, then we need 25 shifts to complete the conduit installation. If we've got 35 pits to install and we're doing 3.5 pits per shift, then 10 shifts for the pits. If we've got 140 foundations to install and we're doing 3.5 foundations per shift, then we need 40 shifts to do the foundations. Then we can sum these together to get 75 shifts. Now, again, this isn't necessarily 75 consecutive shifts, because the other factor we need to consider is resourcing. If we have 75 crews doing the task, then it's obviously going to be 1 shift to do all the work. If we have 1 crew doing the task, it'll be 75 shifts. So with this information, we want to combine it all together and create the schedule model. So we want to combine the tasks, linkages, and durations into a single model. Now there's lots of different types of schedule models we can use. By far the most common, the one you'll recognize and the one everyone uses, is a Gantt chart. But we've also got things like milestone charts or linear schedule models or staging plans that have different and specific applications. So as you progress in your career, I'm sure you'll see these other types, but really the basics is you just need to know how to use Gantt charts. What is a Gantt chart? A Gantt chart is basically a list of activities, and against each activity, we display the time as a bar. Top across of the schedule, you have the calendar, and then against each activity, so task 1, task 2, task 3, you'll have a bar that shows the start date and the finish date. So basically it shows all the activities, the planned beginnings and ends, the activity durations, and the overall start and end dates of the project. And there are lots of different software tools we can use to build a Gantt chart or build a schedule. I'll break these software tools down into two categories. The ones that we would be using as project engineers and the ones that the project controls and planning team will have to use. The ones that the project controls and planning team have to use are way better, way more sophisticated, but also way harder to use. When for us and the type of scheduling we do as project engineers, the really, really simple and basic ones will suffice. So for example, as a project engineer, you'll probably be using Microsoft Excel, which is really good for simple short range programs that you have to update all the time. But also you should probably know how to use Microsoft Project. So Microsoft Project is probably, I would say, is better for more medium range programs, like a 6-week look ahead, or if you're trying to do a full activity program for a larger scope, you want to be using Microsoft Project. And then the planning team will be using things like Primavera P6, which is probably the most common one. And that is for creating an overall master project schedule that has thousands of tasks, shows you the critical path, shows you your resource levelings, and basically shows you everything you need to know to run a project. But that's what the project controls, a planning team are going to be using. As project engineers, depending how your company operates, we're probably not going to be using Primavera P6. Let's now look at an example of how to do this, how to combine this information together and using our task list, linkages, and activity duration to create a really basic Gantt chart. The first thing we want to do is we want to set up our Gantt chart. So we'll start off with all the activities we've gone through, listing them out on the screen. We then want to set up columns for the activity precursor, the start date, the finish date, and the durations. So our schedule starts with earthworks being finished in Zone 8. So we need to get this milestone date from the earthworks program. So for us, we've said 1st of March. Then we want to list out for each of the activities, the activity precursors. So for pits, conduits, and foundations, the precursor is activity 2.1, which is the earthworks being complete. For the supply and install of the light poles in Zone A, the precursor is activity 3.2.1.1, which is the pits, conduits, and foundations being done. Then we want to take our durations that we estimated and put these against each task. So for the pits, conduits, and foundations, we've said 75 days. For the supply and install the light poles in Zone A, 20 days, and so on and so forth. The activity start date, so the date an activity can start, is the finish date of the precursor. So the dates pits, conduits, and foundations can start is the date that earthworks in Zone A finishes. So when there's a lag between activities, so using the example of our foundations need to be done, and then we need to wait 5 days for the concrete to cure before we can stand the light poles, the start date of the following activity will be the finish date plus the lag. So if the foundations finish on the 15th of May, if we can start standing the light poles on the 20th of May, 5 days after this. So when we've got multiple predecessor activities, so for example, the supply and install the circuits, there were 3 activities that needed to be done before this task could commence. The start date of an activity with multiple precursors will be the latest finish date of the previous activities. And then once we've populated all our tasks, for every task, we've got the precursors, so what has to be done before, the start and finish date of the task. And then all we need to do is plot that on a Gantt chart template in Excel, and there we've got it. We've got a completed Gantt chart for our project scope. You can see the pits, conduits, and foundations for the longest period of time, and then the subsequent activities after that. And then we've got a finish date for our street lighting in Zone A. Once we've created our first cut of the schedule, we then need to optimize and analyze it. We need to determine if the schedule we've created is right for the project. Are we going to hit our finish dates? And are we going to violate any constraints? We need to ask ourselves a series of questions. Are we going to meet the finish dates? Are there any interim milestones we need to meet, and are we meeting them? What's the critical path? Which activities have float? Are there ways to minimize risk? And overall, is it correct? A really important concept we need to understand is the project critical path. Now, the critical path is probably one of the most confused terms in construction. At its basic, a critical path is the sequence of activities that, if delayed, delay project completion. So for example, if we're building a building and the project starts, we first need to do the foundations, but to start the foundations, we're waiting on the design. And before we can start the design, we're waiting on the notice to proceed from the client. If the client delaying giving us the notice to proceed is pushing out the duration of the schedule, then that notice to proceed is a critical path activity. If an activity can be delayed without delaying project completion, then it's not a critical path activity. Not all activities are on the critical path. And I think that's the key thing people confuse. How do we know what our critical path is? Well, there's a short and long answer to this question. The short answer is that the software tool that we're using is just going to tell us. And the long answer is we'll have to do a forward and backward pass to calculate the activity float for every single activity and then work out which activities have zero float. Now, I'm not going to cover how to do a forward and backwards pass because it's pretty time consuming. And in reality, you're just going to be using a software tool that tells you what the critical path is. But if you're interested in learning, we've got a full construction project scheduling course that shows you how to do it. But I don't really think it's a super valuable skill because in practice, no one does it by hand. If we understand the critical path, we understand what is driving our project duration. We also understand what we can actually do to change the duration of the project. Now, this is one of the key benefits of construction project scheduling. You can actually change the finish time of the project. And so if we're violating any constraints in the schedule, we have to look at the critical path. We have to know what the critical path is, and then we have to look at what we can do to change the project duration. So we need to speed up our project if we're violating a constraint. We need to know how to speed up an activity. Now, there's two sort of ways we can do this. We can come up with a smarter way to do something. So this might mean a better methodology, better planning, better preparation. There's lots of things we can do. Now, we should do that for all activities. We should always be thinking of better ways to do things. Then there's another set of tools we can use to speed up an activity. And these tools add cost and risk. Now, there's two groups of these activities. There's where we crash the activity, which means adding additional resources to complete it faster, or we fast track activities. This is where we overlap activities. For example, if we're putting up the walls of a building and then painting it, instead of finishing all the walls and then bringing the painters in, we might finish 20% of the walls and then bring the painters in early. So the tasks are overlapped. So we're actually painting at the same time as we're putting up the walls. This adds risk because what happens if the painters get ahead of the schedule and run out of work to do? Then we have to pay to demobilize them and bring them back. If we just didn't overlap the activities at all, then we wouldn't have this issue. So you see, these activities where we're going to spend money or add risks, we should only do them for critical path or near critical path activities because there's a benefit to speeding up these activities, but there's also a cost. When just coming up with smarter ways to do things, we should be considering for all activities on our project. And now we come to what I was talking about at the start when I was saying the scheduling is an iterative process. We're now going to go back. Now we've analyzed our schedule and optimize it. We're going to go back and start looking at all the tasks. We'll be starting to add in discretionary dependency. So we'll be considering our resource levels more, the staging. We might even consider doing less work in winter when it's going to rain. These are all the things we need to work together as a team and come up with to produce the best schedule possible. Once we've improved and optimized the schedule, we need to get schedule buy-in. And this is another step everybody misses and people don't think about. There's no point creating a schedule if people aren't going to follow it. That's the point of scheduling. So we need to get agreement and buy-in from our stakeholders. So these are our internal stakeholders like the construction team, project management, the commercial team, our subcontractors. And then we also need to get buy-in from our external stakeholders. And basically the goal of this is ensuring the plan is realistic, everybody's happy with it, and we're actually going to follow it. So who needs to agree on the schedule? Well, these are the key parties. We want our subcontractors and suppliers to agree on it. We want the client to agree on it. We want the internal project team. So these are our project managers, our other project engineers, other teams, our supervisors and foremen and workers. We want them all to agree that it's a good and realistic plan. And then we want our external stakeholders to agree on it. So we want the people we're impacting by doing the works, if they're impacted, that they're happy with what's happening. Okay, so we covered the 6 steps we need to follow to develop a schedule. Let's now look at some specific applications on real-life construction projects. The 6 steps are our fundamental project management concepts. So these can be applied to a broad range of schedules on a construction project. And regardless of what the schedule is, the principles are going to be exactly the same. These principles are going to be applied to developing our master project schedule. So the project controls and planning team will be using these when they create the overall plan of everything from design to pre-construction to construction and commissioning, grouping these all together when they create the master project schedule. And as project engineers, we're going to use these same principles, albeit on a smaller scale, when we're creating our mid-range to short-range programs. So when we're building our 3-week look ahead, we need to go through and think through what are all the tasks, what order they need to be completed in, how long are they going to take, and then we need to be showing this 3-week look ahead to our other supervisors and foremen, making sure they agree with it, making sure we haven't missed tasks. If we're managing procurement, we'll need to use these same principles. So when we're doing procurement, what are all the packages we need to prepare? What are the steps in producing the package? And then even the design team. So the design manager will work out what are the steps in producing the design? What are the different design gates? When do these design gates need to be met? And so basically, these same fundamental construction project management principles, these 6 steps that go into developing a schedule, are going to be used for creating all the different types of schedules in our project. So whether they're the master project schedule that covers everything, or a 3-week look ahead for the construction of a bridge foundations, the principles are exactly the same. And to conclude, as a construction project engineer, what are your roles and responsibilities going to be in developing a project schedule? So for the master project schedule that's created by the project controls and planning team, you're going to need to be providing information and support into this. The planners will want to know activity sequencing, quantities from the design, input from subcontractors and suppliers, and really you'll be coordinating, preparing all this information, but you're not going to be the one on P6 physically doing the tasks. Then, for the main types of schedules we use as construction project engineers, the short range and mid-range programs, this is where you'll be taking these 6 steps and following them through and putting them into practice. So when you create your short range program, you'll need to know everything that needs to be done in the next 3 to 6 weeks, how long each task is going to take, what's the order it needs to be done in. Then you'll be the one putting this together in Excel and Microsoft Project. For our subcontractors and suppliers, they'll be giving us a schedule of how they plan to be doing the works. So we'll be wanting to check this. We'll be wanting to make sure it doesn't violate any constraints. We'll be wanting to make sure the information the subcontractors got when they prepared this schedule is correct. So for example, our structural steel subcontractor, is the date they have where they're planning to start the steel erection correct and in line with our concreting subcontractors programs? So as project engineers, it's our role to coordinate this. We'll be wanting to check everything in their schedules and make sure it's correct. For procurement and design, again, we're not going to be trading these schedules, but we need to be able to understand what information is in them and what the impact on us is, but also providing input for tasks that we're managing. In summary, we covered the steps to develop a construction project schedule. So these are the fundamental project management concepts. We covered these 6 steps: creating our activity list, our work breakdown structure, putting all these tasks in order, estimating how long they take, putting them together in a model, optimizing and analyzing this model so it's correct for our project, and then getting buy-in from our stakeholders and making sure everyone agrees that we've created a realistic plan of how to do the project. We also spoke about how these six steps are fundamental project management concepts, and they're going to be applied to all of the different types of schedules used on a construction project. And we finished by looking at the specific roles and responsibilities of a project engineer in managing a schedule. So I hope you enjoyed this video. And as I mentioned at the start, myself and Ashley are preparing this sequence of talks to cover all of the core construction project engineering and management skills. We're going to be covering in other videos, other components of scheduling, but also procurement and contracts, quality management, design management, estimating, and cost control. And if you enjoyed the video, make sure you head over to our website. I'll put a link in the description to Construct IQ and see if there's anything there that we can offer you that will help take your career to the next level.